And we'll do that here first. We want to talk about the remainder and factor theorems. We want to talk about the rational root theorem and also something called Descartes' rule of signs. So just a couple tools in your tool belt for how to factor and solve polynomials. So hopefully this question as we open today is review. Can you guys all just do that? Ready, go. Like long division. Okay? Just like elementary school. I even made this one all coefficients are positive. Right? Yeah. Okay.
If only you remember.
So help each other out next to the people next to you at your table. Yeah, I can do that for you here too. I'll do the first step for you. 3x plus 2. There you go. You're welcome. Okay, you do the rest.
Give us a refresher.
Yeah, help each other out. We already did count that one. Hold each other's hands. Help each other along.
This is a really deep conversation.
Like, no, we can't. How many times is 3x going to be x cubed? That'd be x squared times. So then you subtract 3x cubed plus 2. It does. If it doesn't, you subtract 2 to the next term, 5x
Yeah, you can do it right there.
No, that's when you plug in the remainders. The remainders here is when you plug in negative and
Yeah, I think there might be a little bit more on this.
Yeah, you put it on the board for everyone at home, all the viewers at home.
Oh, how is
x squared is supposed to go over 5x squared.
You have to do that.
Yeah, I mean, Katie's going to go viral.
Katie, you're going viral. I know. I'm really
No, not too much. But it's close to
What it is that failed. Yes, we tried to do all the classes so that's like filters and some weird why is it that learning out about character? It's just kind of smiled at you. Really
while she's finishing putting that up, can I just remind you of, I don't know, have you multiplied using the box method before? What's the box method? So say you have like 2x squared plus minus x plus 7 or something, right? And you're multiplying that by x minus 5. Okay, so have you done this before? Okay. So the way you multiply these, it's just a way of organizing your work. When you multiply a trinomial by a binomial, don't you want to like multiply everything that you can possibly multiply together? So this ensures that we get them all, right? So this is 2x cubed negative x squared and 7x, right? And this is negative 10x squared, 5x. Have you done this before, or you've seen it maybe? And negative 35. And then combining like terms gives us our answer, 2x cubed, negative 11x squared, 12x, and negative 35. Yay! Am I right? Have you seen this? It's just one way among a couple different ways that are available to you to organize your work. And it's also helpful too because it helps you see that really you can kind of think about it almost as area, right? It's like length times width equals the blue area, right? You're just multiplying the sides together of rectangles if you want. So would it work to do this in reverse? I've written, you've done a nice job up here too. Thanks, Kate. Okay. But could you do, I just wrote this division problem in this form, right? And what is division? If not like a question about what was multiplied. Isn't it like I have the answer to the multiplication? I multiplied some unknown thing up here by 3x plus 2. And I'd like to know what it is. Yeah? Here we go. Well, what was this box? What is this box? Do some backwards engineering. This is a separate problem. But what will go in this box? If I know this was 3x cubed, this is just 3x cubed. And then this is like a little detective work here. What must this be then? Width. Length must be, in order for this product to be what it is. Yeah, okay, good. Now what's this box got to be? It's got to be 2x squared, right? Because we have the length and the width. What's this? If this is going to be 5x squared. So what is this? So what's this? Not all at once, everybody. Okay, you're overwhelming. You're following Cassie, though? All right, what's this got to be? Someone other than Cassie. It's got to be 6x if this is an 8x. And then what does that mean this is? It's got to be a 2. Do you see the answer emerging? Okay. All right, and then now we run into a little bit of trouble. That's a 4, right? And we're not quite there yet, right? So how about we need 3 more? Okay. So, huh? Oh, have I? Okay. Anyway, so do you see, I just want to make sure at all points that you're making sense of the algorithms that you're using. Feel free, actually, at any time you like to do this instead, right? That's also division, isn't it? So, and that works faithfully every time. If you like that method I just drew, it'll work. Right? Now, one question that came up as I walked around was, how do you report your answer? It's great, everyone got this successfully. I'm feeling good, Mr. Chase. But what exactly did I do? Right? What did I do? Let's talk about how you might report your answer. Here are 2 ways that I think are powerful to represent the work we just did. This one is nice. We're going to take the dividend and have that. We're going to write equals divisor times quotient plus remainder. Now, why does that make sense? If someone asked you, let's forget about polynomials. If someone asked you, what's 22 divided by 7, say, wouldn't one good, well, first of all, what is that? 3 with the remainder of 1 or something, right? So one way you could report that is by saying, hey guys, 22, isn't that 7 times, that's the divisor, times 3 plus 1? Isn't that a good way of reporting that division? In fact, if you take a number theory course, this is actually the definition of division. This is what we mean by division. Okay. In the context of the previous problem that we just did, there's the work, right? So that would be us reporting in polynomial form. I think you can see why that's a useful and powerful way to write it, because really what we've done is you can kind of think of this as a rewrite on the original polynomial. Here's one way to write our polynomial, and over on the right side, here's another, right? And all it would take for you to check your work is just to multiply this out and see that, in fact, on the right, you do have what's on the left. So you can see that that's useful. Fraction form looks like this. And this is maybe actually the one that you're more comfortable with from elementary school. 22 divided by 7. Don't you often report that this way? The answer is 3 plus 1 over 7. Yes? 3 and a 7. Isn't that often how you reported it back in elementary school? Both are good. They obviously say exactly the same thing. Here it is with our polynomial stuff. What is the difference? The only thing I did going from up here to down here is do what? Look at the form of these two equations. What's the difference? They communicate the exact same information. But say like you mean it, Grant? Right, I divided every single thing by 3x plus 2, didn't I? So, but conceptually they do communicate something slightly different maybe, but they all contain the exact same information. Now one more question just for fun as a follow-up. I want you to take in this last result right here, in this line, I know it's a lot of x's and all that. Can you go through and just plug in x equals 10 everywhere? I just want to make sure you understand that at any time in your life, any time, the x's that appear in math class, they can be values, can't they? They can actually take on values. Let's not lose sight of that. So plug in 10, please, and then answer the question. What 5th grade problem have you just solved? So plugging 10 in, you might be like, oh, I don't want to do that everywhere. So what do we get? 3 times 1,000. So what's the numerator there? Oh, it's just 3, 5, 8, 7. Okay. Divided by, oh, this isn't too bad, Mr. Chambers. Oh, wait. Please don't mention the magic trick. Please don't. Okay. No, equals 112 plus 3/32. All right, so, and by the way, so I want to make sure you're clear on this. What we just did was we've not just done a polynomial division, but we've also done regular division. This is actually the same thing. I just want to make sure it's not like this is analogous with this elementary school style long division. They're exactly the same thing. Okay, there's no difference at all, in fact. So, right, remember that x can be a number. Just remember that in life. Okay. Fun problem. Okay, moving smartly along. Let's try another one. And this time, again, I want to have you focus on, hopefully you get the right answer, but I want to have you focus on, can you write it in polynomial form and in fraction form? Actually do that for me here. Make sure you understand how to do that. And in a minute, I'll have someone write up just the answers. I'm not going to have you show the work on this, but you need to do it. Oh no, it's over there. What is it? It's 3.5x, right? Your 7 halves x. I mean, excuse me, 3.5. Slip. You win this time. Yeah, it's just 3.5. Or 7.5. So you don't put it there. Not the word, just the answer, the polynomial form, write it down, and you want to do both, and then also the fraction form. Does that make sense? Like, I don't actually care about the long division work. I just want to see the answers.
I only did polynomial.
Okay, you can do that. That is, so which form is that? Or no, it's actually a fraction form. So is this what you guys got for, which is this? This is f divided by d, right? I don't have room to write it out here, but isn't this is 4x cubed minus 8x squared plus 2x minus 1 divided by 2x plus 1 equals this. Then that's a plus. Is it a plus? Plus 2, is that plus 22.5? Is that what it is? I mean, that might be, I'm just going by my memory here. I don't know. Is that what you get there? Yeah. At the end? I think the remainder is negative 4.5. I think you should check for your sign on the last one. Okay. And then that's fraction form. Okay. Polynomial form would be, we didn't write it up here yet, but it would be 4x cubed minus 8x squared plus 2x minus 1 is equal to 2x squared minus 5x plus 3.5 times 2x plus 1 minus 4.5, right? Right? Yeah, Daniel.
So when I was dividing...
Hey, hold up, guys. This might be a good question. You don't know. It might be good.
When I was dividing...
Hey, guys.
I got to the point where it was 4x, so it was like 4x cubed minus 8x squared, and then you had to subtract that by 4x cubed minus 2x squared. And I was wondering why the minus sign didn't apply to the 2x squared, making it positive.
So whenever I do long division, let me go back and look at how Katie did it a second ago. It is very easy to make a mistake with signs, isn't it? In fact, let's. I think. Am I right, Katie? You mean this, don't you?
Yeah. Oh, I could.
Okay. Yeah, and I just here you were fine. Everything worked great. But let's make this our practice. Put parentheses around this thing and put a minus out front on every step. So that then you're like, oh, okay, now I pretty clear what I need to do. I need to make sure that the negative gets applied across, and right. So be careful. Make sure the answer.
But shouldn't it be for?
Should check carefully your sign, because I think can we just get some consensus that Cheyenne is right here. Is everything else? Is this okay now? Okay. So I think you're maybe making some small error somewhere. Just be real careful with your work. I think you'll get it. So, okay, good call. All right. So this brings to mind something to me. My question is, like, what would happen in this polynomial? What would happen if you plugged in negative 1/2? Can you tell me what you would get? It's not easy to see, is it? But isn't this polynomial the same as this? Tell me what happens when you plug in negative 1/2. What do you get? Do you get negative 4.5? How can you see that so quickly? I'm still over here. 2 times negative 1/2 squared is how can you see so quickly that this is just negative 4.5? In this form, why is that obvious if you plug negative 1/2 in? What do you see, Disha?
I just looked at the 2x plus 1.
Yeah, and then you're like, who cares what this is? If I plug in negative 1/2, I'm definitely getting negative 4.5. Yeah? You see how we rolled there? Okay. All right, so let's do that now. In general, if we divide d of x, if that's just is this just a linear factor like we just had, x minus 5, then what happens? Well, we can write the function in this form, right? And now the question is, what is f of k? In the last example I just gave, I plugged in negative 1/2, right? And that you saw what happened. So in general, what will it be? Just this is not a coincidence, that's all I'm saying, what just happened. It'll always be r. Because that thing goes to 0, we just get f of k equals r. So, this presents an interesting idea. If we want to know what the remainder is, say we don't care to do the division problem. All we want to know is the remainder. What is the remainder, right? Then, if I'm dividing by like x minus 3, all I'd have to do is plug in 3 to the polynomial. And I would get the remainder. Now you might be thinking, why would I ever not want to do the division? Why would I only want the remainder? Doesn't that seem silly? Can you give a reason why you might want to know just the remainder? Why do we care about the remainder? Huh? We're especially interested in the remainder. Sorry, that's the answer to that. Well, here, we'll show you on the next slide here. So there it is in formal sense, and we've already derived it, but there it is, right? If you divide by x minus k, then the remainder is r, right? So and we just proved that. There's not much to say here, right? It's certainly true that if you plug in k, if x minus k is what you're dividing by, then f of k is what you get. So let's find just the remainder. And again, you might be thinking this is such a silly question. Why would I care about this? But let's talk about the remainder on each of these. So if you divide by x plus 3, this polynomial, what did we just learn? If you just want the remainder, what can you do? Yeah, plug in what? Yeah, careful, negative 3. So I'm just asking, what is g of negative 3? And here I'm asking g of something, and here I'm asking g of something. Tell me what the remainders are, right? Because theoretically, this is all we have to do is plug in those values. So tell me what you get. First one, Maria, yeah. No, okay, I'll come back to you in a second. Chris, did you get the second one? 0. 0, okay. And then Grant, what about the third one? When you're ready. Negative 9. It's not. I'm going to confirm these, by the way. Just check on these. And Maria, do you have the first one yet? Where are you? Do you have the first one? We'll plug in negative 3. Is it negative 5? Can someone just verify? Yes, yes, yes. Okay. Right, wonderful. So, cool. Good job. You found the remainder on division. Now you could do the whole division problem and see that that's in fact what happens if you wanted. Is there anything interesting about what you see there? And which one of those is most interesting to you? And why? Jasper? Why? Yeah, I mean, if there's no remainder, you might be thinking, isn't it silly to only want the remainder? This seems like such a useless theorem. Don't we want to do the division problem? And the answer is maybe not. Maybe we're really, really interested when the remainder is 0, right? So let me, before I actually reveal the factor theorem, let me just go back to this one we had up here a second ago. Oh, there it is. What would happen if the remainder was 0? If we had done this division and this remainder was not negative 4.5, it was plus 0. What have we just found? Yeah.
It means that the divisor is a true factor of the original.
Yeah, and what I have written here in polynomial form is not just like the reporting of our division. It's also the if this is 0 here, then it's also the factorization of the polynomial. If this is plus nothing, right? Which is like a powerful idea. Okay, so that goes to, and again, all this stuff, it follows almost immediately on the heels of the previous things we've been saying all along. But of course, if the remainder is 0, then it just basically goes without saying that this is a perfect factor, right? That x minus k is a factor. It's a big idea. So if we can, this gives us a little bit of a way in. Imagine, like I said, that there'll be a time soon when I give you like a 5th degree polynomial and I'm just like, go. Factor it. Well, if you can find your way in by just even finding one factor, then now you have a new problem. You have just the 4th degree to work with. And then if you can find just one factor that you kind of are unlocking it piece by piece, right? All right, we should also remind ourselves what about synthetic division. Maybe people like synthetic division. So go ahead. Do you remember how to do it? You know, refresher? It's easy to forget unless you actually like kind of think through again why it works. So let's do it. We'll do it together a little bit. At least we'll start here. And then my question to you would also be, why does this work though? So you don't ever want to memorize an algorithm. Again, think about long division. Make sure you understand why long division works. Why does it connect with this box method? Do you like that? Is that conceptually useful? And then also, don't just settle for magic here. Also, make sure you understand why this works. Yeah, you remember this? So the first hint I'll give you in the direction for why this works is that we're really just removing the context a little bit. We're going to take away some of the x's and things. So we're just going to actually write the coefficients here, 7 and negative 20. This is a nice first easy one to use. By the way, when you divide a quadratic by a linear, what degree thing, quotient, do you expect? Yeah, we expect a linear, right? With possibly a remainder. So this is how we roll. Here we go. So you drop the 3 down to here. And again, I'll just do this like magic style. And then afterward, you come behind me and see if you can explain this. Do the long division off to the side and see how it connects. Maybe it's the same thing, right? And then we multiply. Every time we're going to multiply by 2. So 2 times 3 is 6. And then we add down and multiply again. Can you finish it? 13 is, yeah, good. And then multiply again and add. What do we get? 26. So what's the end 6? Okay. So what do we just do? Well, for those who might remember synthetic division, it's what do we have? What's the answer? Yeah, 3x. We said it's going to be linear, so 3x plus 13 plus 6 over x minus 2, right? So again, I would challenge you to like explain why that works too. And also remember that synthetic division is this little cool, slick way to do it. We're often dealing with linear factors like this for reasons that you'll soon see if you don't already. And so it's really not a huge limitation to us, but obviously this doesn't really work unless you have a factor of this form. Okay. One other caution I'll give you that you might remember if you've done synthetic division before is if you're missing any powers along the way, like if this was 3x cubed, plus 7x, you need to have a 0 in there as a placeholder. Just like you have zeros in numbers when you're doing division, right? Like if you're dividing with numbers, we use zeros as placeholders too, right? All right, I think that's where we maybe need to stop, I guess. So, yeah.